Okay, so when you look at that term, dot diagrams, what might be the first thing that comes to your mind? Right. So what that is based off of is, you could say, not so much the configurations, but more so the Bohr models. Okay. One of the aspects that I was going to place into your amazing race was, besides, one of the clue was, I'm the only letter not on the periodic table. It's the letter J is not on there. Okay. Oddly enough, I think if you didn't know anything about the periodic table, I think the number one answer would probably be either Q or X, and of course both of those are on there. Q is not very well known. It's a man-made element. It's number 104, uniloquatium, I suppose is how you'd pronounce that. It's located right here. And someone might say X. Of course, we know X is incorrect because of xenon, and then number 30 is zinc, so it's not the letter Z. But another aspect, I didn't know how you dealt with the clues, but I was going to say the last one would be you had to write down the element that's the same number as your grade. Sodium. Okay. So when we do this, again, this is what these dot diagrams are based off of. This is old news. We know that for the element sodium, it's got 11 protons in the nucleus that would go from your the Afal-Abu principle or slide rule, 1s2, 2s2, 2p6, and then, or 1. I always like to put just an E on there, because when you put a 1, it might blend in with the line. So when we add up the letters and numbers, we know we get 11. There's 11 electrons, 11 protons, therefore adding up to 0. So if we look at element 17 then, we know is what? Okay, so doing the same thing, 1s2, 2s2, 2p6, 3s2, but 3p what? 3p5, okay? So what happens then, another aspect on what you could use the periodic table for is that sodium forms a what charge? Forms a positive 1 charge, because what happens is this guy goes over to there, so this is now gone. Yeah, and that's table salt. Okay? So that's now empty. And what we see happening is this outer energy level is now what? 8, so it is full. This outer energy level has how many? 2, 5, and 1 gives you 8. So therefore, they are now more stable. So what does that mean? The dot diagram comes from the Na portion for sodium, which had 1. There it is. So we'll just mark that as a dot. Okay. Then when we look at the outer energy level here, okay, typically that E's not there yet. So how many dots or X's does chlorine get? Okay. And we can determine that because of what part of the periodic table tells you that you want to put 7 on there. The column that it falls into. Remember, do not count the transition elements or transition metals. That is the middle row or D block. So we just use S and P blocks here. Okay? So, therefore, what we see happening is Sodium is in column 1, so then that meant it had 1 valence electron. Chlorine, being in column 7, has 7 valence electrons, 5 and 2. So what happens is, to become more stable, chlorine wants to gain 1, sodium wants to give away 1, and then that is, in essence, what happens. Therefore, this is a little bit of forecasting, but then from physical science, this is nothing new. This has a +1 charge, because if we take 11 plus a -10, what do we get? And if we do the same thing over here, we take 17 and add a -18, what do we get? -1. Okay? So that's why you see those charges in the boxes then. And then the X's and dots here represent what column they are on the periodic table. Sodium, column 1, 1 valence electron. Chlorine, column 7, 7 valence electrons. Therefore, we want to satisfy what's known as the octet rule. And if you had to guess, because you may not remember, this is a specific bond. Do you think it's a covalent bond or an ionic bond? Are you sure? Yeah, it's an ionic bond. Okay. Typically, the most general definition is between a metal and a non-metal. Okay. Of course, there are what we consider exceptions to the rule. You could say, well, hydrogen fluoride. Hydrogen is not a gas, but it's still in column 1. Even though it's not a metal, it's still in that same column because it has metallic-like characteristics. In other words, hydrogen has how many valence electrons? 1, because it's in the first column. Same as sodium. Yes? We haven't discussed covalent bonds yet. Okay? This is ionic bond. Yep. That's why they're called transition metals, because they can vary between having their different charges. So a lot of that goes into different, what we call hybridization, on how these elements bond with one another. That's more so of a well-advanced chemistry concept, one that you may encounter in college, but for this level, we're not too concerned about that. Okay. Probably the best way to look at something like that is when you look at a lot of the D block elements, especially elements 21 to 30. Is that scandium to zinc? Does that sound right? Okay, so probably one of the best ways to look at that is the majority of them, if they don't have more than one charge, is probably +2. A lot of them probably have at least that charge. So if we go from left to right, scandium, there's an exception, +3. Titanium has +2, +3, +4. Vanadium, +2, +3, +4, +5. Chromium's got a +2. Manganese a +2. Iron, of course, +2. Then especially when you get further over here to the right-hand side of that block, okay? Now, this is one of those aspects you probably cannot visualize the answer to that question unless you write it down. Why do you suppose we would say that all of them have a +2 charge of some sort or another? It's something that we had discussed, but you probably can't see it unless you write it down. But why do you suppose they all have a +2 charge at least? Okay, well, go ahead and pick any one of those elements of 20, no, let's say 27 to 30, pick one. Okay, so 28 I heard first, so that's nickel. Okay, so then when we look at element 28, let's just go ahead and look at our board model. Okay, so 1s2, 2s2, 2p. You don't need to be writing this down because you already know this information. Okay, I lost my train of thought. 2p6, 3s2, 3p6. Okay. Now I'm willing to bet you can probably answer that question. It's got 2 valence electrons on the far outside. Okay, so that's why this is probably the most common charge for the D block elements, because that 4s2 is filled up. Like I said, once you see it, yeah, I know what that means now. Of course, it's old news when we look at it, but now that you can actually see that, when we're talking about the hybridization, okay, you notice that a lot of those elements have +2, +3, +4, +5. What you see happening is a lot of these electrons, they will start jumping up into this block and start pulling them away too. Okay, probably one of the most, you want to call it humorous ways of looking at the periodic table. Said this was when you were a freshman, so it's 2 years ago. All right, so you could say, I want to make sure I had the microphone on here, is we said the ladies are all in column 7, the guys are everyone else to the left. Okay, because, all right, we could say, give me a halogen, we'll just use chlorine for example. Okay, so nickel here is pretty nice because he's got these 2 valence electrons, so we're just going to do this very quickly. I didn't say that. Okay, so now with what we see happening then is we'll just write this as E and E. Okay, make it a little bigger there so I got that purple here. Okay, E and E, and then, well, what happens? One's going to go here, the other one goes down there. Okay, so it's kind of like nickel had those 2 extra electrons, which you could say are quarters or dollar bills or $5 bills or whatever. Okay, and then nickel's such a good guy, you know, it's kind of like you're going out on a date. Well, you guys, you got to pay for all that, right? So then chlorine here, you know, she's willing to grab any bit of the money that the guy's willing to give up. I mean, isn't that how that goes? Those arms are just flailing to grab some of that money. Okay, but my apologies though. It is meant in good humor. Maybe it's not good taste, but it's supposed to be in good humor. Okay. But what does it have to do with my dreams? Oh, okay. Well, you know, sometimes I think But anyway, so hopefully it's not that that's a great analogy, but I think for the most part it's a humorous one, and it's a way to lighten up the atmosphere. Hmm. Hmm. So, right. So again, with nickel, the easiest way that this bonds, of course, is it takes these two electrons out of there. Now you've got two less electrons, making this a plus two. So then when this goes through the process of hybridization, it takes one of these out of there then too. And that's a concept that we really don't need to be discussing at this level. Yes? For each one, yes. Yep. Because if we had, and you've seen this before, okay? You have to do it this way, okay? Okay? Because the number one mistake that people are going to make is they look at this. Now, but not you people. You won't do this. We know the symbol for nickel is Ni, okay? So then we know the symbol for the chloride ion is Cl. So since this is a plus 2, that's a minus 1 for each one of those electrons that was given up. The least common multiple is 2. 2 divided by 2 is 1. And then 2 divided by 1. This has nothing to do with the value. It's not a negative 1 value. It's a negative 1 charge. Okay? So then 2 divided by, if you just want to say 1, you can do it that way. 2 divided by 1 gives you what? And again, that's why you have to have 2 of them, and that's why we drew 2 of these up here. So if you had that vanadium, like you had just mentioned, it has plus 5, well then you'd be just illustrating the same thing with 5 chloride ions, or chlorine atoms, whichever way you want to look at it. Okay, so why do you suppose we got that Roman numeral there? Because it's a plus 2, because nickel can also be a plus 3. So that's why we really don't, we have maybe done probably no more than 5 of these when you were a freshman, but you have to know the charge. But once we get up to this level, we should be able to determine that, okay, we know it's nickel 2. We said always go by your negative ion. That's always going to be set in stone. Whether it's hydroxide being negative 1, carbonate negative 2, phosphate negative 3, any one of those, you always go by the negative charge because you know what that is. Now, does that mean that you have to always start with a negative charge? Well, no. If you had potassium chloride, you know that potassium's plus 1. You can just go ahead and start with that because that's in column 1. You just want to always start with the negative ion, especially when you're dealing with D block elements. The transition type, it's either one or a different type of charge, and that's why. Are we on the bus? Okay. So what we will do is, what do you suppose is the simplest covalent bond? Hydrogen and hydrogen. Because you might be asking yourself, now wait a minute, we had just said that hydrogen has metallic characteristics and it forms ionic bonds. Well, yes, that's true. Everything you're saying is true, but you'll find out that there's going to be exceptions to the rule. And especially for those of you who go on to take organic chemistry, when we start talking about different types of naming, there's going to be exceptions to those rules too when you name them. Just to give you an example very quickly, is that for instance, this is something that you would be familiar with, and that is this compound right here. When you look at that, since it has an OH group on there, we know that it's an alcohol, and since it's not on the end, whether here or here, that would denote it being propanol. Okay, but I see the flyers being listed out in amongst the school that October 11th is time to be given flu shots. Okay, I get a flu shot now. You people, you obviously you don't have to. Okay, but is it a good idea? Well, yeah, my opinion is, but it's not my job to tell you what to do with that. That's your parents and guardians' choice to tell you whether you should get one or not. But if this is not propanol, it's called isopropyl alcohol. Why would we put flu shot flyers together with isopropyl alcohol? It's also got another name to it. Rubbing alcohol. What does rubbing alcohol have to do with the flu shots? Yeah, that's right. Okay, so what we see happening is when we have some of these different types of derivatives, now this isn't going to make any sense to you because you just haven't applied it to anything. When we say X marks the spot and how some of these derivatives, which we call, you did discuss those, a methyl group and an ethyl group, you remember that from physical science, okay? We know that on a parent chain, okay, we know that that's a methyl group, okay? So where X marks the spot, we could say CH3, that's a methyl group. But what happens is if you extend that out a little bit, that's now what we call isopropyl group. Now, don't get propyl mixed up with propanol. Those are two totally different concepts, and we're not discussing them right now. But are you writing this down? Why? No? This is organic chemistry.
I wasn't sure because we're going over it. See you on the test. All of it.
Okay. But anyway, so what we see happening is, okay, if we see a butyl group, a T-butyl group, an isopropyl group, then a methyl group, okay? We need to place them in alphabetical order. Okay? So, MITB, which one comes first? Okay? So, we'll go ahead and place this as number 1. Yep, that's true. Okay? You want to place this as number 2? Okay? That's wrong. That's wrong. Because we said there's exceptions to the rule. Okay? What that means then is this is just a prefix. You don't go by the T in T-butyl. You got to go by the B. So that was already in alphabetical order, but it was just a trap that. Oh, is that a Big Bang Theory type thing? Well, it is sort of. It's. Oh, that's a trap. It's that other personality that comes out. Have you ever heard of Me, Myself, and Irene?
Oh, I love that.
Well, you had, yeah, it was. We had you had Hank, and Hank was the bad guy, and Charlie. Charlie was the other one. So, so when you say that, which person's coming out, Jordan? It's not you. It's Hank. No. Dan. Well, the reason that's so funny is I can't picture anyone that's named Dan without laughing, especially at the beginning of Despicable Me 3. Well, if you remember, he's got the diamond, but his clothes Gru's clothes got ripped off. He's holding the diamond. He's stuck in that bubblegum balloon. And he's going by the building in that office party. Happy birthday, dear Dan. And he is kind of like he's out there.
Someone anticipating that stupid. So he's standing there holding the diamond with no clothes on.
Yeah.
He's in a bubblegum balloon.
Standing there.
Someone just walks in.
Not standing.
Chemistry sounds about right.
Okay.
And he flies past the office building in the balloon.
Oh, speaking of that, wasn't that the best clue to get to this room? This room is the best for a million reasons.
We just read Minion.
Yeah.
He just read Minion.
Was it Williamson? No, just Williamson. Yeah.
Okay. All right. So when we're talking about the simplest, okay, just got a little bit left, then we'll be done. Okay. And that is, okay, the simplest covalent bond is this one. Okay. Because they're sharing each electrons now. Now you want to write this down. This is the simplest covalent bond, okay? Because these electrons are not being transferred, they're being shared, okay? So the same thing that happens with all molecules, especially if they're diatomic, okay? So for instance, fluorine, okay, we know is in column 7. We established that with chlorine because it's a halogen. So is this. So since that is the case, okay, fluorine gets 7. Then there's another fluorine here because it's F2. Okay, and we've satisfied that octet rule because each one of them now has 8 electrons around them, and inside the box, that's where you see a bond when those 2 electrons are going back and forth between, they're sharing that, okay? So this also is an exception to the rule, okay? All halogens, except for the bottom one, which is what? Astatine, AT. Okay, that's, for one thing, it's not a liquid, a gas, or anything to that effect. It's a metalloid, actually. Okay. So hydrogen would be an exception to the rule. We know that helium is an exception to its rule as well, because noble gases typically have how many valence electrons? 8. They all have 8 with the exception of hydrogen. So, or excuse me, helium. So that's why when you look at that table, there's always going to be, well, not always, but sometimes there's exceptions to rules that apply. It used to be that, let's say, in volleyball, it used to be the official, I always call them up and down. I don't know if that's right. The up official, of course, up on the ladder. It used to be they would have their hand, or they put their maybe their index finger and thumb on the net when someone's about to serve. Okay. It used to be. I thought that if on a serve, if it hit the net, it's not a good serve for a point. Now, maybe that was before rally scoring, too. That could be. But what I'm saying is, you could say that at one time was an exception to the rule as well. That if you serve, it hits the net and it goes over, now the point is good. Where it used to be that it wasn't. Okay.
They just felt movement. They're like, no.
Yeah, they would just blow their whistle immediately. Just like at some times, have you ever noticed when, if you have I can't put myself in this category if I said good line judge, because I do it all the time, and it doesn't make me a good line judge. But when they're standing there, where should they be looking when you're serving? Why?
So you don't cross.
Okay, because because when you're standing there, I just look, and then if you can see they're this far back, even a cross-eyed baboon could see that.
Do they know what the cross-eyed baboon is?
No. What's that?
I don't know. I've never seen one before. Pay attention. What? This is important materials. What?
You ever seen a cross-eyed baboon?
Okay, anyway. Are you going to show me the cross-eyed?
Well, should they see a cross-eyed baboon? Yeah, because like I said, if you're looking down, even a cross-eyed baboon could see that.
I didn't know there was a reenactment.
Oh.
for it was bad.
But you've never seen a cross-eyed baboon.
No,
Well, see, now you have,
Oh,
right?
yeah.
Huh? Now you've seen a cross-eyed baboon.
Tell me. Dude, actually,
It's a slapper.
Yeah.
It's a great joke.
Yeah.
Thomas is actually.
But see, but yeah,
Eyes are never.
if I know that someone's serving and they're this far every time, I'm just not even gonna look. I mean, your peripheral vision. If they score next time, I better be looking, because sometimes that does happen. More so during JV, someone might step on or over the line and they don't call it. But for instance, when you're talking about that serve, if that happens, you just raise your flag right away. But sometimes what happens is that ball is going over the net. The officials are already looking to the other side, so you just got to be standing there going like this, waving your flag. It's a good thing it's not white. You surrender. Okay. Well, surrender yourself to this. Surrender yourself to fun. Yeah. So we'll pick up with this information again tomorrow.